Welcome to the Heat Treat Podcast, sponsored by Matza, Creo, and Super Systems.
A new episode of the Heat Treat Podcast today. Two crucial elements in the heat treat industry, especially when it comes to aerospace applications. Joining us is Andrew Bassett, CEO of ATP, a leading pyrometry lab and expert in the field. Andrew, thank you for being here. It's a pleasure to have you here finally.
Thank you, Carlos. I've been fine for us.
Andrew and I have been trying to arrange logistics and times for about a year. So because Andrew is a very busy man, a businessman, and a great engineer. So I'm sure we're gonna have a blast. So thank you for being here, and so you can share the basics of what you do, how you help the industry, how you serve it. But let's start with the basics. But before that, can you give us an introduction of your company, of your career, how you started, and now that you're a very big leader in the sector, what are you looking for? Are you envisioning for the future?
Sure, absolutely. So my start in this career kind of was dating a woman whose father had a pyrometry business that he started in 1956. And she ended up becoming my wife, but he was retiring out of the business. Her brother was taking the business on, and they needed some help. My degree is in communications for radio broadcasting, and but when I found out I was going to literally starve going in that industry, I took this left turn in Albuquerque, so to speak, and got into this pyrometry field.
I must say that you have like a radio voice. You have a deep voice, so it makes a lot of sense.
I don't know about the picture stuff, but that's why I wanted to be behind.
Yeah, no TV, but radio you will fit fine.
That's what my dream was. But that was dashed when I found out I was going to starve. But so yeah, that was early 90s. 1992 is when I got involved with this company, who's still in business today, and still do a phenomenal job out there for their clients. But that's also the time when NADCAP was starting to take its foothold in the industry. And I was lucky enough that some of my, one mentor in particular, who's still involved with the industry, Ed Engelhardt, the quality director for solar atmospheres, dragged me to my first NADCAP meeting and says, hey, if you're going to be, understanding this, you need to understand NADCAP, and brought me to my first meeting at that time. And that's really what my involvement started with pyrometry and understanding the major requirements when it came to the aerospace industry and AMS 2750. So from that standpoint there, I worked with the company for about 9 years, moved on to a couple other different organizations before I started aerospace testing and pyrometry in 2007, after working with several different companies. And just kind of wanted to get to start this company with a customer focus in mind. So since that time, when we were just, primarily in pyrometry services, going out and performing pyrometry for not only aerospace, but for automotive, food and drug, anybody that needed calibration requirements, we took care of it. We've kind of expanded on that. We now have our laboratory that's based in Ohio. So we do calibrations of test equipment and secondary standards. We have our consulting and training arm. So we do consulting in NADCAP, automotive CQI9, training to these requirements as well. And then our latest venture for the last several years is the aerospace compliance software. So, we're starting to build this little compliance industry, compliance for not only the heat treating industry, but we've gotten into chemical processing, composites, welding, medical, it's automotive. It's really expanded into different areas of manufacturing and thermal processing equipment.
So are you expanding besides heat treating?
Oh, absolutely.
If I understood it correctly?
Yeah,
okay.
We do a lot of composite facilities that have, basically they're big giant ovens, but, the composite industry, chem processing has, chemical tanks that need calibrations, as well as ovens that get doing drying and baking processes. Hell, we even have a company down in New Jersey that does dehydration of chicken for dog food. So, I mean, we're not going to be exclusive to the aerospace industry, but they have requirements for, the dog food is been dried correctly. So we'll do it across the board.
So let's start now with the basics. Thanks for the introduction. So pyrometry and calibrations.
Yes.
Why are they so essential in industrial furnaces, particularly in the sectors like aerospace
Sure.
or automotive?
Yeah, I mean, it really does. When it comes to the pyrometry aspect of things, I always have said that we're a necessary evil. You have industry specifications, be it automotive, be it aerospace, that have requirements to have this stuff tested on a periodic basis. Okay, we want to ensure that the instruments for calibrations, the ones that are controlling the thermal processing, is correct and making sure that's accurate, but it goes across not just the calibrations. There's other testing to make sure the whole systems are in place and correct for the whole system. For instance, system accuracy testing or probe check in the automotive industry, you're checking not only the controller, but you're also checking the thermocouple and making sure that meets applicable specs. I think a lot of people, when they're dealing in thermal processing, especially new people, hey, you calibrated my instrument, it said it was 400 degrees, but it's not really 400 degrees because my parts are over baking. Well, yeah, that's one aspect. We make sure the instrument's correct, but the rest of the system could be wrong. So, it's just not it's like your oven at home. You set it for 350 to go bake a pie. People think it's actually 350, but I've even thrown thermocouples in my own oven to see how they are. And it's not because the rest of the system is not correct. So we want to ensure that, why the importance of pyrometry is to make sure that the thermal processing is actually seeing the heat that needs to do to, make metallurgical properties or bond materials correctly in the composite world. That's the importance of it.
So you mentioned about the thermal industry and compliance, which compliance will be like a big word on this podcast today.
Sure.
But when you talk about compliance, there should be a standard to comply with. What are those standards? Can you explain how those standards are set? Because I also know that you are very involved with boards and committees that actually decide the standards with the aerospace companies or with the automotive companies. But when you need to comply with something, and standard has to be set, but how and why those standards are set, and could you elaborate on how the pyrometry then affects operational safety and compliance of the part?
Sure. So you're correct. I am heavily involved in the aerospace pyrometry spec, which most people are familiar with in that industry, AMS 2750, which is the main pyrometry spec for all thermal processing. That's the main pyrometry spec that during NADCAP audits are looked at. That they have their own separate checklist just on that specification alone. And I got involved with that specification when they were revising it from letter D to Rev E. And at first, I really got some pushback from some of the members of the AMS team saying, hey, we have industry experts already, involved. And I, finally sat down with the spec custodian of the spec, and I said, look, I'm not disrespecting you at all. You've been working for Boeing for 30 years. But when's the last time you've actually picked up a thermocouple and tested it? Use it to a testing. And he said, yeah, probably 30 years ago when I was a lab rat at Boeing. And I said, well, I do this for a living. And I understand where you guys are coming from, that you want to make sure this industry is correct, but you don't have anybody on your team that actually does this day in and day out. I have to live, breathe, and comply with this spec for not only us, but help our customers understand it. So from that standpoint, thankfully, the chairman of AMEC, that's the Aerospace Metals Engineering Committee that I belong to, that's the think tank that writes the aerospace standards, heard the conversation, goes, absolutely, you need to be on that team. We need someone like you to get involved so you can have some sense of reality. That's, what's best practice and what's actually can occur. And so thankfully, I've been on that team since the revision E. And now we are on revision H right now, and we actually are starting revision J on the next iteration of the spec. So Currently, I'm actually the most senior member of the team. All the people that I started with in Rev E have either gone away by the wayside and retired or whatnot. But yeah, now I'm the most senior member since, of being a part of that committee. And I don't plan on going anywhere anytime soon. I want to make sure this standard, that aerospace standard, is clear and concise for the end users. When it came into the realm of NADCAP, and this was well documented within the heat treating task group, that the findings during a NADCAP heat treat audit, 80% of the findings came out of pyrometry. So in my opinion, shame on the team that's writing this spec if it's too hard to understand and there's too many interpretations. So we've been working on making clarity out of that specification. And that's actually one of the biggest reasons why, instead of revising it every 5 years as the requirement by SAE, which owns the specification, we've asked for permission to revise it every 2 years. So if things come up in that 2-year release, we can go fix it in the spec on the next revision and not wait 5 years to have clarity. So that is one of the actually biggest reasons why I plan on sticking around on the team until we get to a point where that specification is understood by anybody who can pick it up and read it and understand the intent of the specification. Then I'll be a happy guy. Then I can, pass it off to somebody else.
And let's talk about technologies that make this precision possible to meet the standard. What are the tools and calibrations today to meet the standards?
So you mean working with the standards now and how that's kind of created?
Yeah, well, you created the standard, right? Based it on a specific need in order to meet
Sure.
a certain
so from
spec,
the standard standpoint,
right?
and especially now as we're revising it every 2 years, there's always going to be questions regarding what the intent and the requirement is. So a lot of times it comes out of audit findings. Maybe it's misinterpretation from the auditor.
Yes.
So when that happens, we get wind of this misinterpretation and say, you know what, we need to clarify this a little bit better in the next revision. So, if we need to make the team as a whole, there's 12 of us now on the team. When I started, there were 7. And we have a huge, a huge array of experts on this team, and from different parts of the countries or different parts of the world, a part of the team, as well as different industries as well. We have raw material suppliers, we have aerospace primes, we have commercial heat treaters, we have a pyrometry guy, we have thermocouple people. So we have these industry experts. So when these things come up, we can go ahead and address it. Or if it's in between revisions, we have parking lot issues that we just put it in the parking lot to work on for the next revision. But if interpretations come up in the meantime, we can circulate, hey, this is what the intent of the specification is. Maybe these findings need to be, voided or put away. So, when we do make changes within the specifications, we just don't do things just because we want to make everybody's lives miserable. It's actually, we have to, when any changes to any of the aerospace specifications, we have to be data driven. So we have to, it's just not saying, hey, this is best practice or this is what we think is best for the industry. We actually have to have data to back that up. So for instance, when the biggest uproar that happened several revisions ago is when we made this requirement for 0.1 readability on digital recording devices. And everybody was up in arms about it, saying, hey, if I'm hearing a job and it's for plus or minus 10 tolerance and my recorder goes to 10.1, does it fail? Well, technically, yes, because we added the 0.1 readability on it. Well, why is it why is it so strict? The metal's not going to know the difference and so on. I understood their technical arguments about it, but to be honest, we were actually fixing a flaw in the specification since the spec's been released. We talk about everything is in units of Fahrenheit in the specification with the subparagraph of everything in Celsius. For instance, a calibration accuracy of a furnace controller needs to be plus or minus 2 degrees Fahrenheit or 1.1 Celsius. So if you don't have readability of 0.1, how in most of the rest of the world besides the US processes in Celsius, and except for the US, so how do you show compliance if you don't have 1.1 readability? That was really the intent of the change in there. So, again, when we're making these changes, it's data driven and not just thinking, hey, we feel like just making your life a little bit more miserable to comply with this. That's why there's so many different people involved in the standard, because they have a vested interest as well.
And we touch on the standard committee, but when you work with a user, it's the other side of the coin. They do feel that you're making their life miserable and more expensive.
Absolutely.
Right? But it's in order to ensure the quality of a critical component that might go on an airplane and is gonna keep life safe, right? But from your experience, what are the best practices for implementing an effective program to meet the specifications in an industrial plant for a commercial industry, a commercial heat treat that they don't have maybe a skilled guy, but they have a lot of will, but they wanna learn. That they're eager to learn. I mean, they want to comply with to enter a new market, let's say, and that cash is not raining, right? So those things can get pretty high budget if you don't have a clear vision on how to implement it.
Sure. So implementing any kind of pyrometry program, and it doesn't necessarily have to be aerospace, automotive, or compliance. I still think pyrometry can be used as an effective tool for tracking the health of thermal processing equipment.
Correct.
Years ago, I sat in on a symposium of the future of heat treating, and there was a gentleman there who I didn't know at the time was doing one on pyrometry, and he was supposedly an industry expert, and I'd never heard of the gentleman, so I decided to go down to see what he was going to talk about 2750 on, and he did a phenomenal program of using that standard not as a tool for compliance, but as preventive maintenance, taking the data from pyrometry testing, such as calibrations and SATs and your TUSs, and trending that data to start looking at your furnaces and catch it before it gets out of camp, where you're not, where the furnace may be out of tolerance and now processing bad parts. So instead of using it from a compliance standpoint, it can be modified if you don't have to comply with the standard, but at least you can use it for, hey, let's trend our furnaces. Let's see if there's issues with our furnaces. It's a great preventive maintenance tool. The biggest challenges I see, though, with commercial heat treats or anybody that has to apply to this spec, and they're like, okay, we want to manage this pyrometry in-house, is giving the resources needed for whoever's performing it. Pyrometry guys, people like me don't fall out of trees very often. And so you want to make sure that training is imperative on understanding what the requirements are and how to test it, and not taking the shortcuts that people like to take. Oh, we just need to get this done. Just do your thing and just give us a report and we'll put it in the file. No, a good pyrometry tech is going to be able to start understanding the equipment over time as he's testing it. Hey, my results are starting to trend in this direction. Maybe we need to get maintenance involved, or maybe this person is maintenance. Oh, let's open the door. There's a big chunk of insulation or brickwork missing, and that's why it's cold in that area. And this all can be done through pyrometry, testing. So the challenges, again, I see is finding good pyrometry guys. And if you do have a good pyrometry guy, you know what? You better pony up and pay them, because they're worth their weight in gold, in my opinion. It's having that person give them that ownership of that equipment, and then having senior management giving them the resources to make things right. And that's, again, I see that a lot sometimes as a flaw is, well, we just need it from a compliance standpoint, or yeah, you did your test and we'll just put those results away and nothing gets done out of it. Well, then what's the purpose of doing it at that point? So having a good pyrometry tech maintenance background is always phenomenal, making sure that he's taken care of, from a financial standpoint or whatever, and then giving them the resources to be successful in what they're doing. So those are some of the bigger challenges that I see, that commercial heat treat, captive heat treaters that are doing this internally. So and then making sure that that person's also continually being trained up on whatever the latest and greatest requirements are.
Talking about the different markets and but the same industry, which is heat treat. I know that we have talked heavily about aerospace, but there are some other very big players in the market, which is automotive right now, defense. Now is space exploration for many companies, maybe mining. There's going to be more fracking and oil from this Saturday and on. But can you briefly explain how the standards are different from each industry to other? I mean, it's pyrometry and calibration, right? But each industry, I assume, has designed its standard to meet certain things, right? Like the aerospace, I will assume not planes to fall over, right? So engines can actually last. But can you briefly explain how what are the key aspects of every market that they look for in a good pyrometry and calibration
absolutely.
program?
So, one of the other industries that you left off that list is medical.
Medical,
that's right. You get those dental drill bits or hip joints and that kind of stuff.
Right.
Actually, the FDA adopted AMS 2750 as the pyrometry spec.
Really?
Yeah, that's an aerospace material spec is now in commercial work for medical device manufacturers. So if they're heat treating this stuff, they now have the requirements to follow AMS 2750. Auto has their own version of pyrometry, which is the CQI9 standard. CQI9. My understanding, they're in the middle of their 4th edition rewrite of that standard. And so when I do a lot of pyrometry training, I talk, mostly it's always been, AMS and aerospace standards, but we do CQI9 as well. So a lot of times,
will you say those are like the two most the big ones, the most common
absolutely.
ones?
Those are the two main specs that are out there. Now there are.
I mean, I seen the bearing companies that they have also take CQI9 standards as well. I don't know if that you've seen those.
Yeah.
It's not automotive, but bearings are being specified to meet CQ9 standards because of the good practice.
Yes.
Have you seen that?
I have not seen any commercial facilities using it as like their standard. Most people, again, it's a necessary evil when you have to deal with either CQI9 or the AMS or the aerospace standards. But commercial shops, like I've dealt with some mining facilities, like oil and patch type of heat treating stuff, and they really don't follow anything. Like, okay, just test my furnace once a year and it's good enough.
Right.
It's going underground. Well, yeah, it is going underground, but you know what? I hope it doesn't break a well and we have a bigger environmental issue here. So, that's the kind of things I concern myself when it gets to other commercial industries that aren't regulated as much. But the automotive has theirs, which has always been, I've always said it's kind of a diet version of the aerospace standard. I'm happy to know that when I can get on an airplane, I know anything that's been heat treated on that, especially the new aircraft. I'm not going to go into the overhaul and repair business, but I'll talk about when it's a new aircraft, all those parts are nice, bright, shiny new, that they are going to be safe. When you look at the automotive industry, and I'm probably going to get a lot of hate emails on this or whatever, but if you take a comparison of what's happened from a heat treated related issues of, let's say, a plane going down because of a heat treated related issue versus automotive recalls during heat treated related issues, the automotive is here. Planes are non-existent. I don't remember when the last time a commercial airline has gone down because of a heat treated related issue. But was it last year or 2023? There was this huge recall of Kia and Hyundai vehicles. That was because the piston rings seals were not heat treated properly. And so I've always said that the automotive requirements for CQI9 are a little bit looser than what we have on the aerospace side of things. So, but that's just my own opinion. Like I said, I expect some hate mail coming in on that one. But, I know with the aerospace, I've always kind of not joked about it because it's kind of sick humor, but I'm like, the automotive industry, yeah, they might have 500,000 cars recalled because of and maybe it's, maybe because of the recall, maybe killed a couple families of four because the car leaked oil and burned them up. Where a plane goes down, it's going to make some news because you've just killed several hundred people in an aircraft and it's heat treated related. That's going to make more news than a couple cars burning up on the side of the road because the piston ring was no good and it, caught on fire. So, that's kind of like my comparison, really with the aerospace and the automotive standards. Those are your two main bodies that everybody follows. Now, there are other pyrometry specs out there that need to be followed too, but that's inherent of certain aerospace primes have their own requirements as too.
And now let's talk about the future.
Mm-hmm.
The heat treat industry is evolving as well. Tolerance has getting tighter now with the EVs. The big specifications to meet requirements, and there seems to be like a need. Well, the market is actually, customers are asking for tighter and tighter requirements, quality, in order to avoid failures. How do you envision that these pyrometry programs or specifications are going to evolve? Are they going to get more complex, more essays, more less margin of error? More, what do you envision? Because this has evolved over the last 30 years when nobody, I mean, you used to do service on a notebook, right?
Yeah.
With a stopwatch, right? And now there's very big high-tech companies that are doing this, SCADA systems that are tracking databasing and, following on real-time data with alarms and spikes. But things have gotten so much complex. There's a lot of data that it's being stored, maybe not analyzed, but it's being stored just in case, right? A lot of more calibrations, essays with much more certainty. How's it gonna look like, and is it gonna be cost effective still?
My goal is, as being a member of the in the aerospace realm and what I deal in the aerospace and pyrometry in general, is I don't want to get to a point where we're over testing things and getting it more stringent and stringent. I'm not a scientist, I'm not a metallurgist. And so when I throw things out there with other team members within our group or within the AMEC structure, as we're going through, various specifications, I'll be the first to raise my hand and saying, why are we making this tighter? Is this going to make the part any better? Is it going to make it more stringent? Is there less risk by doing this? By making things tighter and tighter. Yeah, there's going to be less risk, but where's that risk? Do we need it here, or is this still okay? Why are we going to handcuff the end users of these specifications by creating real tight requirements? So we need to look at the cost. That's a major thing, because if we have these tighter requirements instead of, hey, we need to check this every 3 months instead of every month, well, yeah, the cost is going to be a little less checking it every 3 months, obviously. Those type of things. Why are we going to over test things, or why do we need to have such strict tolerances if it's not going to have any kind of metallurgical difference to the parts? So, that's always been my goal since joining on the AMEC team, is making sure that at least my voice is heard. I'm just one of a few members of the, of the team. I want to be that voice of reason. Let's not, if it makes sense and the data is there that, hey, we're having problems with, widgets, aerospace widgets going out or whatever's going out from a heat treating standpoint, yeah, maybe we do need to tighten things up a little bit, but we're not seeing those, at least I'm not seeing those problems. I'm not privy to those problems that are ending up out there in the manufacturing.
I do believe it's a fine, very practical, and just your expression and how you use it about it. We don't want to over test things as well, because we add cost and we do not add value to the process itself. But we're in a super safe spot that is just adding more dollars to the end user. So this is a question. Would you have imagined when you started your career on pyrometry and calibrations that it was gonna get up to this stage?
No, I mean, no, I didn't think it would ever get to where we are now. I mean, it is amazing from a standpoint, like from the technology that has changed over the last 30 years. I'm still dumbfounded, and then sometimes it's hard for me to keep up from year to year of the technology position system looked at. It's amazing. I mean, I'm 30 plus years of dealing with this stuff where we had, basically meat thermometers checking our ovens and that kind of stuff to, now you have control systems that and calibrators that pretty much, the only thing they don't do, and I'm working on that one, would be to make an espresso before I start my calibrations. But, these systems are so advanced these days that it's amazing from that technological standpoint of how these furnaces are controlled and how they can be maintained and how that data can point you in directions to keep your process running more smoothly and efficiently.
I'm going to walk in very dangerous grounds here with the next question.
Sure.
But with such sophisticated technology, I imagine there's margin of error, right? And what are some of the most common mistakes companies make when handling this pyrometry and calibrations with such advanced technologies?
Well, I think the biggest thing is some of my favorite words. We've never done it this way. That's the biggest mistake that I always see. Is not being open to the technology that's out there. There is a lot of technology. I mean, a lot of it is old school. Hey, we haven't done it this way. This is how we've always done it. And opening yourself up to, hey, there's stuff out there that's going to make your life a little bit easier and more efficient. And at that point, you're actually going to start making some more profits on your runs. So that's another goal of ours has always been is, hey, why don't we look at ways from a pyrometry standard, how we can get you to, instead of having to test your furnace every month, because that's what the requirement is, your current status is. But if you open your horizon a little bit and we add, let's say, a thermocouple to measure your parts, a load thermocouple, hey, your testing can now go out to every 3 months. So in other words, if I take 8 months of my services out of your pocket, that goes back into your pocket that you're not seeing, and you're not over testing equipment. So those are some of the common mistakes I see is, and again, it's the lack of understanding what a supplier can and can't do. And, and that really it is the adage, I've never done it that way, or I don't understand. I want to be the educator and say, these are things that can be done. You're not over testing. You're still going to be producing quality parts, and you have stopgap measures in place in case something does go sideways. So that's probably the biggest one I see.
Andrew, it's been incredible talking to you about pyrometry. Your expertise, it's invaluable, especially for industries like aerospace, which you are actually contributing a lot. I know those meetings are very fun, right?
Oh, sure.
They can get very fun. Very technical.
We have a different idea of fun,
right?
I'll tell you that
All
much.
right. But before we wrap up, is there any final advice you'd like to share with our listeners? I do believe that in our industry, I'm talking about the heat treat industry, we are losing talent. Their talent is retiring or is going somewhere else at a much faster speed that we are recruiting it.
Absolutely.
Right? Or keeping it. But for somebody that wants to make a career on heat treat, and in your case, pyrometry, specification, quality, is there a final advice you would like to share with them?
Yeah, I've been a big pusher of, I'm sure you're familiar, and I know you are, with the Metal Treating Institute and their big initiative of Jobs of Tomorrow. They have developed a 6-part series on looking at getting younger people involved into the heat treating industry. And it's just not, what people think the heat treating industry. It's actually very fascinating and interesting. So I've been telling, people, younger people, hey, go check this out. Heat treating is actually a pretty cool industry. Again, 35 years of doing this, I can still stop at a forge process and stare at it and like, that's pretty cool. Or additive manufacturing and see that and be like, that's still cool. And that I play a part of that process from what I do. And then for companies is to be able to nurture that on new employees or younger employees that are coming in and give them that responsibility, nurture them into the industry, give those responsibilities and ownership of what they're doing. Because a lot of times I don't see that, and that bothers them. Hey, go load baskets, go do this. Giving them the ownership of being able to move forward within the organization. Absolutely. That's my biggest advice I can give is if you got somebody who's young and hungry and ready to work, and you see something then nurture that. Get them moving forward.
Thank you so much for sharing that, Andrew. It's been a pleasure having you on the podcast. And to our listeners, thank you for tuning in. Don't forget to subscribe. If you're looking for a pyrometry expert, Andrew is your guy, right? And talking by phone, he has a very deep voice, radio voice. Now we know why, And until next time, Andrew, we had a blast.
Carlos, thank you. Appreciate it.